Hello everyone, welcome back to another session for optimization techniques. In this session, we are going to have an example for Taguchi method or Taguchi array method actually. In previous session, you have seen about the basics of Taguchi method. In this session, we will have an example for that. First, let's have brief review about what you have learned up to now. If you remember, we had discussed in Taguchi method, we can have different factors, different levels and responses, which usually by design of experiment, we are interested to find out some relationship between the factors and responses. But in by introduction of Taguchi method, you have seen we can also select between the factors which we have to find the maximum or minimum value for our response or responses. So, for example, imagine in cooking of the cake, we can have factors like oven, sugar, flour, or eggs, which can have different levels like temperature, for example, for oven. It can be prepared, the cake can be prepared with different temperatures. The sugar, its values based on the measuring cup. The flour, also the value or amount of that based on the measuring cup can be different levels for this factor. And for the eggs, the number of the eggs or the quantity of the eggs can be the levels of these factors. All of these factors can be effective, this level of factors actually, or even the factors itself can be effective on the desired output, which is the quality of the cake, which can be taste or color. In this kind of the problem, what we are going to understand actually is the desirability by the user. For example, the taste or color can be determined by the user. Here in Taguchi design method, which we are going to have an example for that, the objective is to develop a Taguchi design array with three parameters. With three means three parameters and two levels. We write like this: three parameters, and each one of these parameters are into level. This is the simplest uh, design of experiment based on the Taguchi design array method. What we are going to do is to predict maximum outcome from the design array in this example, which we are going to have. After that, we will see how to perform confirmation experiments if we need, and also how to perform follow-up experiment. This is the objective of the example which we are going to have in today's session. Our example is to find the best combination to give best results to clean your bathroom. What are the factors here? The factors which we have selected them are material which can be used for this cleaning process, which has two levels: lemon and vinegar can be two different materials. The parameter 2 is tool, the tool which can be used for this cleaning process. It can be cloth, it can be sponge. And the third parameter is the time, the duration which we do this cleaning, which we select two different duration for this cleaning for our two levels of these parameters: 5 minutes and 10 minutes. It can have other level, as you can see here, for example 15, 20 minutes and so on. And for the tools we can have other levels as well. For the material also we can have other choices, but we have selected here is the simplest array which we can have two levels for three parameters. Okay, now we are going to understand how we can run an experiment with the minimum required of the tests to understand which combination is more appropriate or more desirable here. One method which we can do is factorial design. I will show you the table for that after this, but this is our purpose to use Taguchi method. Later we will see how statistically can we reduce the number of results. In other words, to have minimum experiments and find the best combination of these different parameters. To do this, we cannot actually, one of the methods is this, to develop the array to predict optimum results. Optimum results means the highest quality of the cleaning. So we need to develop an array in row and columns for Taguchi method. But we need to follow also two important rules for developing a design of experiment based on Taguchi method. First, rule number one, each level of each parameter appears in the same number of times in the array. Rule number two, repetition of parameter level combination are minimized as much as possible. So we have two rules to develop an array. If you remember, array means a string of the numbers or parameters. So you will see the power of the Taguchi method after this by these two rules only. Taguchi DOE is a robust method that drastically reduces the number of tests. This is the main reason for us to use Taguchi method to find optimum results. Thus, reduce cost and also save the time. This is the power of Taguchi method. We can reach our goal by lower amount of the cost and time. Now let's see how we can develop this array for our example here. If you remember, we have three parameters with two levels. In other words, we have three factors, and each factor has two levels or three parameters, we can say. Full factorial, if we are going to check all of these combination or condition, we need to use full factorial design of experiment, like what you can see here. We need to check all of the materials and tools as a treatment. Then we will have we need to do 8 different experiments for these three parameters or three factors with two levels. First, this is level 1 of the material, level 1 of tools, level 1 of time. After that, it's still level 1 of material, level 1 of tools, and level 2 of time. Okay, then the combination, if you recall from the factorial, we need to have this combination. And it means we need to run 8 different tests to reach to understand the result of the cleaning. And you can see here, minimum, at least we need to 8 different tests or experiments. It can be shown also in this 3D graph. As you can see here, we have 3 different parameters: material, time, and media or tool actually. And for each one of them, we have 2 different levels: level A1, A2 for material, level B1, B2 for tool, level C1 and C2 for time. So this is the 3D visualization of our data point which we can have. And so we need to at least have 8 different tests. But if we follow the Taguchi rules, which we have already seen in above, then we can have such a table. Okay, let's reach this Taguchi table or Taguchi array of the experiments from the factorial design. If you remember the first row is here. Each level of each parameter appears the same number of times in the array. And second rule is the repetition of parameter level combination are minimized as much as possible. Okay, so let's see. Now we have lemon close 5 for the first experiment. We keep that. The second experiment, lemon close 10. You can see here, lemon close is repeated. Then we can ignore this. After that, lemon sponge. If we do like this is better, we remove lemon cloud, it's repeated. Lemon sponge, we just keep one of them, for example. Vinegar cloud, we keep it. Vinegar cloud is repeated. Vinegar sponge, for example, we can keep it and remove these. Let's see what we have. Lemon cloud 5, lemon sponge 5, vinegar cloves 5, vinegar sponge 5. So if you notice here, we have only checked 5 minutes. So what we can do is to keep 10 in some of them to satisfy the both. What we have done is we keep lemon clove 5, the first one, then lemon sponge. This time we keep this one, the time 10 minutes instead of 5 minutes. How about the third one? Vinegar clove 5 this time. Vinegar and clove not repeated, here, and vinegar sponge as our last one. Now we can check. We know from this that we can reduce the number. After this, we can check our tools based on this. But you need to also follow this, because reducing number of the tests, we need to do some averaging to understand the effect of one parameter on another. We will do this also for our experiments, but generally you can see from factorial design, Taguchi design, we just have reduced 50%. Only 4 experiment is required in Taguchi method. If we want to compare for the higher number of factors or parameters and high level, you can see now we have 2 parameters. Now here we have 3 parameters with 2 levels. The number of the required experiment is 8, as you can see here. But if number in factorial design, but in Taguchi method, we just need 4. In when the number of the parameter is increased to 4, number of factor or parameters, and this is level of those factors and parameters, you can see when the number of factors is increased to 4, the number of level for each factor is 3, then totally we need to have 81 tests. However, if we use Taguchi array method, we need to just run 9 experiments. You can see how much this method is powerful to reduce number of the required experiments to reach our goal, which is the optimization, which is the find a relationship between the factors and responses. So simply you can see how we can remove those parameters, and the most simple method to remove those extra experiment which we don't need in Taguchi method is using this visualization. We can remove these points on the lines. You can see we just keep the second one. So when you have two uh, when you have three parameters, two factors, simply by the visualization, just keep this point, this point, this point, and this point can keep and remove the rest. Now we can check also if we follow the rules or not. Each level of each parameter appears the same number of time in the array. So P1 or parameter 1, which is the material. Okay, let's check lemon and vinegar. How many times it is repeated? Lemon 2, vinegar 2. How about the tools, clothes and sponge? Clothes 2, sponge 2 as well. We have in our array. How about the parameter 2, which is time? 5 minutes 2 times, 10 minutes 2 times. So we have this rules. It is satisfied this rule. No number of the repetition for each level of each parameter is 2. And also there isn't any similar, they are not similar. There is no similar test at all, which is the best condition. Sometimes we may need to have some similar tests, but here due to the low number of the parameters and levels, we don't need. Now, after we run the experiments, the results can be measured as well. The results usually here in our experiment, the results are based on the satisfactory level of the person. For example, the cleanliness of the surface, the bathroom. We give that the percentage for the results of the cleaning. For example, when we use lemon as material and we use clothes for 5 minutes, the cleaning result is 40%. When we use lemon and sponge for 10 minutes, then the cleaning result is 60%. When we use vinegar, clothes for 10 minutes, the satisfactory level of the cleaning is 70%, and vinegar or sponge for 5 minutes is 50% of the satisfactory level of results. So these are our results. Now, can we just decide based on this result that, for example, this combination is the best? Which combination gives the best is in the next step which we do. And also, if you notice, we haven't checked some combination here in this Taguchi method compared to factory method. If we check those methods, maybe they have the better results, higher percentage. So how we can be sure that our result is the best? We need to find some average. How we do this averaging? We need to find the average value for each one of the level and material which we have. For example, the average value for the result of the material 1 and level 1. Material 1 means lemon, and for the its first level. As you can see here, we have lemon 40 plus 60, x1 plus x2 divided by 2. 40 plus 60. And for material 2, level 2. How is this average value? Material 2 is vinegar. Then what we have is 70% plus 50%. Its average value is 60%. How about the tools? For tools again, we have tools 1, level 1, 40 plus 70. If you notice, this is tools, clothes, okay, 40 plus 70. Same for a sponge, we need to find average 60 plus 50 here. For the time also we need to do this as our third parameter. 40 plus 7 40 plus 50 40 plus 50 divided by 2, the average value 45%. And for this parameter time, its second level, 60 plus 70 divided by 2 as will be 65%. So we have already found the average value for effect of these parameters. Now we need to draw this graph or plot to find the trend. For the material, for each parameter, we need to draw this graph. Material, tools, time are our parameters. We have two levels for each one of them, and we have already found a average value. This is, the desirability. This percentage. If you notice here, we have calculated this average value. We have calculated. We put here for the first level of the first parameter, which is material. The average value is 50 here, and for the second material at the second level is 60%. So it is like this. The graph which we draw is like this. It has increased from this material to the other material. So better result we can see for vinegar compared to the lemon. How about the tools? You can see it is same. The average value we have for different tools, cloth or a sponge, they are same. So we can say it has no effect, the type of tools. After that, we will also discuss about that, how you can decide about the type of tools, cloth or a sponge, even it is plateau or line not increasing or decreasing. The third parameter, which is about the time, again 5 minutes, 10 minutes, two levels of these parameters, the percentage, the result, the average value are 45, 65. Here, if you remember 45, 65, then it is increasing. So 10 minute cleaning is better than 5 minute cleaning, actually. So it is increasing. We have this kind of graphs, to the trend, increasing, decreasing, or plateau when we have just two levels. When we have more than two levels, we may have maximum or minimum scenario. In that case, we need to discuss more about this. For example, if we have maximum scenario, then this is the best. When we have the minimum scenario, we can decide about that. This option is not good. We can decide about the other two levels. So go back to our example. Now we can find the best combination. For the material, this one is better, vinegar, the second level. For the tools, no difference between them. Let's keep them at the moment. We can use both of them. About the time, 10 minutes is better, the second level. So vinegar, cleaning for 10 minutes, which each one of them will have same results. But now we can decide. Now we can decide about the cloth or a sponge based on other factors, which we have other factors or parameters which we have not included in our example, like cost, availability, or etc. In this case, we can decide about that. For sure, clothes is more cheaper than the sponge, and also it is cheaper than the sponge, and also it is more available than the sponge. So our combination can be vinegar for 10 minutes by clothes. This cleaning will give us the best results, and it is satisfactory. As you can see here, this is our result. We reach this conclusion only by doing 4 tests, and we just have the result for 4 tests. Then we can make a good decision about which combination of the tools, material, and also the time can be used to get the uh, best result, and this is called optimization by Taguchi method. Okay, so this is one method for optimization. Sometimes everything is not ideal. If, for example, if we cannot get 70%, if you remember we had in our result, then we need to run confirmation experiment as well to check what is the real result for this experiment. Vinegar, sponge for 10 minutes, or even we may have for other times to check our results. As you can see here, we can check the cleaning with other material, we can check in other times, and so on, and we may have this result. The cleaning result, this is percentage, has improved, or even it is decreased the percentage, the results. So by this extra or follow-up test, we can decide that our result is really optimal or not. If we are able to do more or extra experiment. Otherwise, we can just follow what we have found, and we need to run the test to check our result, which give us the best and the maximum desirability or the highest result based on the percentage, for example, in our sample, for example here. So by this we reach end of this basic for Taguchi method. You have seen an example, very almost simple method. We need to just follow two rules, and also as you can see, we can do the calculation easier, and we need to just find the average values for our response, and then draw a graph, and based on the graph we can decide about that. However, these days we have a very good software like Minitab or Design Expert software to run the Taguchi method, and just if you know the basics, you can have better explanation about the results. Otherwise, nowadays we usually use software to run the Taguchi method compared to the manual calculation. So we use software also to do this calculation. However, you need to know the basics of the Taguchi method. So by this we reach end of this session, which was about the basic of the Taguchi method.